If circuits feel confusing right now, don't worry. In this channel, we'll make them feel obvious. Hey everyone, welcome to Analog Intuition. Here, we'll learn how analog and digital circuits work intuitively, with minimal theory and maximum understanding. And before we design anything serious, we'll learn how to verify our ideas using simulation. We'll focus on three core analyses: DC, SC, and transient. Alright, let's begin. Today we are starting with the foundation, DC analysis. Let us understand DC analysis using a simple low pass RC filter. If we apply a step signal at its input, for example, the magnitude of step is 5 volts, let us say. Everyone knows what the output is going to look like. It is going to start at 0 volts and it is going to rise slowly and settle at 5 volts. So when we apply a DC source at the input of RC filter, the voltage of the source is 5 volts. It is going to assume that the step has happened at t equal to minus infinity, and it is going to return the settled value as the DC operating point. Let us look at this in LTSpice. Any simulator will do. I am just using it because it is free. So in the file tab, click on new schematic. A draft file will be created. Now we can start placing the components. We will create the same schematic. Select the resistor, place it. Then we will place the capacitor, followed by voltage source. For voltage source, we have to select in component and then voltage. Okay, and finally we need a ground. To connect them, just press W, or we can select wire icon, wire symbol here. Okay. We can pass through the components. LTSpice directly connects them. Finally we connect the ground. For now, let us take random values for resistor and capacitor, since this is a DC simulation. I'll take 1 kilo ohm and 10 nanofarad. For voltage source, we have taken 5 volts. For the simulator options, click on simulate tab and configure analysis, and in DC operating point, just click on OK and place it here. Now click on run button. Now it will give the steady state values of all the nets. Here it is showing that net 001 is at 5 volts, net 2 is at 5 volts, but we don't know which one is net 1 and which one is net 2. So let us name the nets as well. Click on the label net option here. We'll select output and click here. Similarly, we'll also select input and click here. Now if we run the simulation again, we can see that the input is at 5 volts and the output is at 5 volts, and the current through resistor is 0. Now let us do a small modification to this circuit. Instead of applying a DC source, we'll apply a PWL source. And let's assume that step is happening at 1 second. So at 1 second it is still 0, and after that the step is happening and it is changing to 5 volts, and I'll give some random value for the 4th time instant. So it is still going to be at 5 volts. Now let us run this again. So we can see that DC analysis has taken 0 volts as the input voltage. This is because DC analysis is going to assume that whatever value is at time instant t equal to 0 as the input steady state value, and then it is going to apply that voltage and compute the output and return the DC operating point. That's why we can see both the input and output are at 0. That's all for today. This was DC analysis. Next, we'll look at AC analysis and see how circuits behave when signals vary with time. Thanks for watching. If this helped you, subscribe to Analog Intuition, and I'll see you in the next video.